Hello, this is Mrs. Bird here, working on a lesson today, starting our new unit on systems of linear equations. So, when we're solving systems of equations, there are three different types of answers we can get. We know that linear equations will form a line when we graph them, and so we're looking to see whether or not we end up with the same line, which would mean infinite many solutions, two lines that intersect, which means there's one solution because there's exactly one place where they cross, and that would be an ordered pair that we would write. Or if we end up with parallel lines, that would mean there is no solution. So if you'll go ahead and go over to your lesson, it's sideways like this, and I'm so sorry. I can't seem to turn my screen. So if you'll just go ahead, we're going to take a look at this first one right here. And you can just kind of write normal out to the side, but I'm going to have to make mine kind of like this. So what we're going to do is we're going to graph both of these lines, and we're going to look at where or if they intersect. Now, a system of equations is two or more equations. So if we're going to graph, and it would be helpful if you have access to a ruler. Even that one that's in your planer would be really helpful. You can take that out because you're really going to want to make sure your lines are straight. So if we start with this first one, this first equation that I have in blue, hopefully you remember that your y-intercept, that's this number right here. That's what you're going to start with. It goes on the y-axis. I'm going to put y-intercept here. We're going to go on the y-axis to +3, and we're going to put a dot right there. And then we're going to graph our slope. Our slope is always in front of our x, and it is rise over run. So we're going to rise 1 and run 3 from that starting point that we have there. So starting here, we're going to rise 1 and then run 3. So our next point's going to go right there. And then again, we're going to rise 1 and run 3 and put a point right there. Now, if we want to keep that same pattern and go backwards the other way, we can, instead of going up and right, if we go down and left 3, that would still line up on the same line, and down and left 3. If when you go the other way, it doesn't create that straight line, then you're probably not going the correct way. So go ahead and graph that line. You're going to want it to be straight, very straight. Take your time. All right, then we're going to graph the next one. Again, we start here with our y-intercept at +1. So from the origin, we go up to +1. And then in front of the x, you might not see anything, but we know that's a 1. And if it's not a fraction, we can always place the number over 1, so 1 over 1. So starting with that red point, that y-intercept, we're going to rise, and then we're going to run. So we're going to rise 1, run 1. So up and right. Do it again, up and right, up and right. Oh, you can see right there they're intersecting, up and right, up and right. And you can continue that pattern, down and left, until you run out of room. And then nice and neat, connect your points. If you need to pause this at some point, you can absolutely ask the substitute to pause it so that you can make sure that you catch up. Hopefully you noticed that these intersect right here. And so if we need to figure out what that ordered pair is, remember we start at the origin, and we are going to go on the x-axis 1, 2, 3, and then up 1, 2, 3, 4. So right 3, up 4. So we are going to end up saying that we have one solution, and that one solution is +3, +4. That's the x and the y. Now, what that means is that's the only ordered pair that would make this equation a true statement and this equation. What I mean by that is if I plug 3 in right here and I do 1/3 times 3 plus 3, my answer will come out to 4. Just like if I take this 3 down here and I put it here, this one's kind of easy to do. 3 plus 1 would be 4. So this is the only pair that works for both of these equations. All right, let's go down to the next one. Let's try this one. So we're going to start with this blue equation that I have. So our y-intercept, that's always our starting point on the y-axis. So we're going to go up to the y-axis to 4. We're going to place our dot there. Remember, if you do not see anything in front, it's a 1/1. So from our starting point there, we're going to go rise 1, run 1, rise 1, run 1. And then you can go back the other way. Down and left. And then connect and draw your line. Now, just keep in mind that, see, the slope is positive, so the line should be going up. If the slope was negative, it would be going down. So once you get your line graph, stop, take a minute, look back and see if your line is going in the right direction. Okay, let's graph this one. We're going to start at our y-intercept of -2. So from the origin, that's going to be below the origin down here at -2. And then the slope, again, we don't see a number there, so that's going to be 1/1. So we are going to rise 1, run 1, rise and run 1, till you run out of room. And then you can go back the other way, down 1 and left 1. What kind of lines do you see there? Hopefully you're thinking, oh, I see parallel lines. So yes, are those ever going to intersect? No, they're never going to intersect. So the answer here is no solution. So we're looking for the solution. Well, if they're parallel lines, they're never going to intersect. So there's not going to be a solution. So our first example, we had one solution where they intersected. Our second example, we had no solution because they're not going to intersect. Let's take a look at the third one. So we're going to start at our y-intercept of +2. And then, now look, this has a negative fraction here. So that means we're going to go down and right. You're either going to go up and right or down and right. If it's negative, you're going to go down and right. So the top number tells us how far up or down to go. So we're going to go down 1 and then right 2 and put a dot. And then down 1 and right 2, down 1 and right 2. Or instead of down and right, you could go up 1 and left 2, and that would still be on the line. Like I said before, if you try to go the other direction and it looks like it's not still on the line, you probably aren't going the right way. And that line is going down, which makes sense because the slope is negative. Okay, it's really important you keep that in mind. All right, the second one, we start here at +2. And then notice the fraction is negative, so that slope is negative. That means this line is also going to go down. And then we go to the right. So if I go down 2 and right 4, look where I land, right there. I don't have room to go down and right again, so if I go back to my starting point and go up 2 and back 4 to the left, I'm on my line again. So look at this. This line is constantly intersecting with the original line, which means that there are all kind of solutions. It's constantly intersecting there. So we're going to say that there are infinite many solutions. Okay, so we have these 3 examples here. You have quite a few graphs here to try. I think maybe just to get you started, I'll kind of maybe hop on here. Let's look at number 1 together just to kind of get you going. All right, so if we look at the very first equation there, our starting place is at -4. So we're going to go down to -4, and you're going to put your dot. If you don't see a number in front of the x, remember it's 1/1, and it's positive. There's no sign there, so it's positive, so it's going to be up and right. So we're going to go up 1, right 1, up 1, right 1, until you run out of room. This one's going to have a lot of dots, but that's okay. Up and right till you run out of room. And then you can go the other way, down and left until you run out of room. All right, let's try the next one. Now, you don't see a number out here, so that's really like plus 0. So we're going to start at the origin right here, and that's a positive 1/5. So since it's positive, you're going to go up, and then you're going to go to the right. So you're going to go up 1 and right 5, which you can see lands right there, but keep going. Up 1 and count to the right. Whoops. Count to the right 5. Put your dot. Now you can go backwards the other way too if you want. But you already see where they intersect, so you probably could just go ahead, and please don't freehand it. I can't really use a ruler on here, but I would like you to use a ruler. Circle where they intersect, but not just circling it. Go ahead and say, because you can see that it's intersecting in one place, I want you to go ahead and write 1 solution. And then also, not just writing one solution, I want you to put what that solution is. What is that ordered pair? So starting at the origin here, that would be 1, 2, 3, 4, 5. So positive 5, and then up would be positive 1. So the one solution that there is 5, 1. That's the solution. This comes from the x-axis and the y-axis. So if that's helpful, you can put that on there. Okay, so that particular problem had some kind of helpful things. If you don't see a number in front here, it's 1/1. If you don't have a number out here, then it's 0. So keep that in mind as you're working on these. Let me see if I see any. Let's maybe go take a look at number 6. Let's go take a look at number 6, because these are horizontal and vertical lines. So the first one here, y = 3. If we don't have an x and a y in the equation, then it's not going to be a diagonal line. It's either going to be horizontal or vertical. So y = 3 means we go to the y-axis to 3, which is right here. And it's going to go through there. It's not going to go on the y-axis. Some kids will go to here, and then they'll just draw the line here. Well, when you do that, you're saying all the y values are on the line. No, just a y value of 3. So we have to go this way. That way we only have y values of 3 for that line. So that's just going to be a horizontal line. And then same with the x = 2. Go to the x-axis to 2, and it's going to be a vertical line like this. So how many places do you see that intersect? One solution. And what is that one solution? Don't just stop there. What is that ordered pair? Starting at the origin, we got to go right 2, so it's positive 2, and then positive 3. So 2, 3. Okay, I know there's a lot of practice problems on here, but this will be good. This will be really good. How about we take a look at number 11? We'll look at number 11. So starting with that first one, we're going to start at -3 on the y-axis. So we're going to go on the y-axis down to -3. We're going to put a point right there. And then if you look in front of the x, you might not see a number, but there is a negative sign. So it's a -1/1, which means we're going down and right. Because if it's negative, you got to go down. So go down 1, right 1. Down 1, right 1. Till you run out of room. You can go the other way too, but you always start on the y-axis first. And then get that ruler. Okay, the second equation, we're going to start at -5. And then this is the same idea. It's got the negative there, so it's 1/1. So down 1, right 1, just like this. Or up 1 and left 1. The line should be going down when you look at it. If there's a negative slope, the line should be going down. Remember, we read lines the way we read books, from left to right. So as as I'm looking at this direction, these lines are going down, which they should because they have negatives. Now, what kind of lines are these? Hopefully you're like, oh yeah, those are parallel lines. Well, parallel lines, they never intersect. So if they never intersect, then we're going to write no solution. And there won't be any ordered pair to write. So when you have a no solution or an infinite many solutions, that's all you write. But when you have one solution, you need to write what that ordered pair is. And then I think that this will finish it up. So let's see, there's 16, I think, yep, there's 16 of those. And we did 3 of them together. So that leaves you with 13 problems. You got the rest of the class period to work on these. Take your time, use your ruler. You need to make sure you're doing your best to keep it nice and neat. And then just as a little reminder, if you're, let's maybe write this somewhere down. If your slope is positive, you're going to go up and right. If your slope is negative, you're going to go down and right. And you might be like, well, when do I go left? Well, maybe you also put on here that when it's a positive slope and you're going up and right, that's the same thing as going down and left. Those would land on the same line. And for a negative slope, down and right is the same as going up and left. So do your best. I know you can do a good job on this. And whatever you don't finish on this, if you will just use the rest of the class time and then finish for homework.